So as this is a non-homogeneous differential equation, we will have to convert it into a respective associated homogeneous equation. So let's do that. So the associated equation would be y double prime plus y equal to 0. In order to solve such an equation, we should convert it into an auxiliary equation, and then we can find the roots of that equation. So the auxiliary equation is m square plus 1, and let me explain to you why this is so. So we can always write down this equation as 1 y double prime plus 0 y prime plus 1 y equal to 0. So based on the coefficients here, coefficient 1, coefficient 0, coefficient 1, I can write the auxiliary equation as 1m square plus 0m plus 1 equal to 0, which converts into m square plus 1 equal to 0. So now it's fairly easy to see why we wrote m square plus 1 equal to 0 in the first place. So now we're going to find the roots of this equation. So the roots of this equation are m square equal to minus 1, which shows that m equals square root of minus 1, which shows that m equals plus minus iota. So once we have the roots, we just go to the uh, the case 3 of the solution set, and we write down the complementary solution as e raised to the power alpha x c1 cos beta x plus c2 sine beta x. This is the general form of case 3. So if we are going to employ this general form, we must know what alpha and beta are. So the roots can be written like m equal to 0 plus minus iota 1. So in this case, I can easily identify that 0 is alpha here and 1 is beta. I have just written plus minus iota in the way we write a general alpha plus minus iota beta, and I'm getting alpha as 0 and beta as 1. So I'm just going to put these values into the general form here. I'm going to get the complementary solution as e raised to the power 0 x c1 cos 1x plus c2 sine 1x. So yc comes out to be c1 cos x plus c2 sine x. Okay, so now since we have the complementary solution, we will be using variation of parameters to find the particular solution for this problem. And so the formulas are that we need to find W first, which looks like something like the Wronskian, and which should be y1, y2, y1 prime, and y2 prime. And here, what we do is we identify this thing as y1, the first part of the complementary solution, and we identify the second term of the complementary solution as y2, and we then construct the complementary solution, the Wronskian. So the Wronskian will be cos of x, which is y1, then the derivative of cos of x, which is minus sine x. Similarly, y2 is sine x, and the derivative of sine x is cos x. So this would be the determinant that we will be needing in order to use the variation of parameter formulas. So let's do that. Let's calculate the determinant. W equals cos of x into cos x minus sine x into minus sine x. So we get W equal to cos square x plus sine square x, and we all know from trigonometry that it equals 1. So it's a good thing because we're going to have a simpler expression for the formulas of variation of parameters. Formula for u1 is minus y2 f of x divided by w, which equals minus y2 is in our case sine x. F of x is the right hand side of the given differential equation. So this we identify as f of x if the differential equation is written in standard form. So we must first convert the differential equation in standard form no matter how it is given, and then we identify the right hand side as f of x. So we move forward. We multiply this with cos square x, and then we divide all of this with w, which is 1. So we get u1 prime as sine x cos square x. Similarly, the formula which we proved earlier for u2 prime is y1 f of x divided by w. So we get, so in our case, y1 is this thing, cos x. So we take cos x, and then we take the same f of x, which is cos square x, and we divide all of this with 1. So we get u2 prime as cos cube x. So now, since the particular solution is based on the values of u1 and u2, but we are having the values of u1 prime and u2 prime, we need to find the values of u1 from u1 prime and the value of u2 from u2 prime. How do we do that? We will have to integrate u1 prime to make u1, and we will have to integrate u2 prime to make u2. So in this case, the integration is going to be a little bit tricky, not too much. So let's do the integration. So u1 equals u1 equals the integral of u1 prime with respect to dx. So we get integral of minus sine x cos square x dx, right? So for this integration, what we can do is we can actually see that whatever is here is available to us here in its derivative form. Or in other words, since we know that cos x, the derivative of cos x is sin x, we can use substitution to make use of this. So using substitution, we assume that u equals cos of x, which shows that du equals, so we simply take derivative of this, all of this thing, we get minus sine x dx. And whatever we have here and whatever we have here, we just substitute these values into this equation, into u1, and we get a simpler form. u1 equals the integral of, so I'm going to replace cos x with u, right? And I'm going to replace minus sine dx with du, right? So let's see what happens. So we get u1 equal to integral of u square du. So I hope you can see how we made the substitution, what we used to substitute into the equation, and I hope that it's much clearer to you now. So the integral will be u cube divided by 3, which is we take back the substitution and we land with cos cube x divided by 3. So here we've got the value of u1, which is cos cube divided by 3, cos cube x divided by 3. So now we will have to integrate u2 prime, which is probably not that difficult. So let's do that. So u2 prime, we found u2 prime as cos cube x. So what we need to do is we need to find u2 by integrating cos cube x with respect to x. So this can be a bit tricky because at this point you can easily make a mistake, and which is that you could simply write, some people make a mistake and they write like cos 4x divided by 4, and then they try to differentiate cos of x in the uh, denominator, which is wrong. This is absolutely wrong. Why? Because you should have, in order to make, this, use the same formula as u to the power n, the integral of u to the power n equal to u to the power n plus 1 divided by n, you should have anything that looks like u and anything other than that that looks like du. So this is not the case here. So what we are going to do, we are going to use integration by parts, and we write down the, we break, in order to use integration by parts, we break cos cube x into two parts. The integration by parts formula goes something like this: integral u dv equals uv minus integral v du. So as you may know that we have to choose u and we have to choose dv from this thing, all of this thing. So you have to break it down into two parts and you have to choose u and dv. So how do you choose u and dv in this case? You take whatever is easier to integrate as dv, because if we choose anything that is more difficult to integrate, so if we choose dv as cos square x dx, it is going to be cos square x dx, it is going to be even more difficult to integrate as compared to just like cos cube x. So what we do is we we choose dv as cos x dx, these two parts, and we take u as cos square x. So du equals, so you take derivative of this equation and you write down 2 cos of x into minus sine of x. Similarly, you integrate this thing and you make v, which is in this case v equal to sine of x. Now you take all of these things and you plug into the formula of integration by parts, and you get, so you write down uv cos square x into v, which is sine x, minus integral of v, which is sine x, into du, which is all of this, which is 2 cos x into minus sine x dx. So let's work with this. Minus, so this minus and this minus, they will become plus. So it becomes plus. This 2 comes outside. So I'm bringing this outside of the integration, and everything else becomes sine square x cos x dx. At this point, you must be thinking that we can use the same substitution that we did in u1 prime, and you're right. We're going to use the same substitution here because we can see that sine x and cos x are related by differentiation. So we can use this fact to solve this using substitution. So using substitution again, we choose u equal to sine of x, and by differentiating this we get du equal to cos dx, cos x dx. So we make these substitutions and we write down cos square x, so all of them, writing all of this down here, sine x plus 2 integral u square du, right? So then we get cos square x sine x plus 2 u cube divided by 3. So making reversing the substitution, we get, because we chose u as sine x, we're going to have sine cube x divided by 3. So up to this part we are really good. We have solved the uh, integral of cos cube x up to this point. So we can write down that this is actually the integral of cos cube x dx, right? So once we get this thing, we can simplify this by taking sine x divided by 3 as common, from all the terms, and we're going to get cos square x plus 2 sine square x. And we're going to have a 3 here as well, because the cos square x didn't have, cos square x sine x term didn't have a 3 in the denominator. So now you're going to write down sine x divided by 3 into cos square x plus 2 cos square x plus 2 sine square x. So you may be guessing where I'm going with this, and the reason I'm doing this is because I can take 2 common here and I can write 2 cos square x plus sine square x. So now we can just simplify all of this and write down cos square x plus 2, because cos square x plus sine square x equals 1. So this is the final form, that cos cube x dx equals sine x divided by 3 cos square x plus 2. So this was actually u2, and we have got u2. So once we've got the values of u1 and u2, u2 I have got here, and u1 I found out here. This is the value of u1, cos cube x divided by 3. I'm just going to use the general form of particular solution from variation of parameter, which was u1 y1 plus u2 y2. So plugging in the value of u1 from here, which is cos cube x divided by 3, cos cube x divided by 3, and the value of y1, which was cos of x here. So I get cos of x plus u2 y2. So u2 we just found out from here. This is, all of this is u2. So sine x divided by 3 into cos square x plus 2 into y2. So y2 was sine of x. So we get here into sine of x. So the final answer for the particular solution is cos x to the power 4 divided by 3 plus sine x to the power 2 divided by 3 into cos square x plus 2. This is the particular solution, and a final step would take us to the complete answer, and which is the general solution y equals yc plus yp, and yc we found out here, yc is c1 cos x plus c2 sin x. So c1 cos x plus c2 sin x plus, so I'm going to write down yp here, and yp was all of this thing, cos to the power 4x divided by 3 plus sine square x divided by 3 into cos square x plus 2. So at this point you may be thinking that the answer doesn't match the answer at the book end of the book. So what we are going to do, we are going to use a lot of simplification which is possible to this function right now. So let's simplify this function. All we need to do is write down. So what I'm going to do is I'm simply going to take cos 4x divided by 3 plus sine square x divided by 3 into cos square x divided plus 2. I'm going to take this and I'm going to simplify this further by first taking common 1 over 3, and what happens here is that once we do that, we get cos to the power 4x plus sine square x into cos square x plus 2. Now we can write down cos square x as 1 plus uh, 1 plus cos 2x divided by 2. 1 plus cos 2x divided by 2. Right? So since here we have cos to the power 4x, we can double this like this, and on the right hand side it's also going to have a square. So I can write 1 over 3 into 1 plus cos 2x divided by 2 whole squared plus sine square x, and I'm going to also write down sine square x as 1 minus cos 2x divided by 2, and I'm going to write down cos square x again as 1 plus cos 2x divided by 2 plus 2, right? So this is what we get. Now we have to simplify this, and for that I'm going to take the 2 common as well. So I'm going to be left with 1 plus cos 2x whole squared divided by 2, because 2 was also as a square in the denominator. So if we take 1 2 outside, 1 2 is still left inside. So plus 1 minus cos 2x into 1 plus cos 2x plus uh, it will be 4 here, right? So then we can write it down as 1 over 6 into, so this is not going to be a 4, because all we need to do is we simply need to, since we took the 2 outside, 1 2 will come outside from this, and there's a plus sign, and the second 2 can either go from this term or this term. So we've just taken this from this term, so this, the rest of this term is going to remain the same. All of this is going to remain the same. So then we write down 1 plus cos square 2x. So I'm going to distribute the 2 to all the terms, plus 2 cos 2x divided by 2. I've expanded the square, and now I'm going to write down another term as 1 over 2 into uh, all of this multiplied by all of this. The formula I'm going to use is a plus b into a minus b equals a square minus b square. So I'm going to use that, and I get 1 minus cos square 2x, and similarly this term is going to be multiplied with this 2 as well. So 2 into 1 minus cos 2x. Similarly 1 over 6 into 1 over 2 plus cos square 2x divided by 2 plus cos 2x plus 1 over 2 minus cos square 2x divided by 2 plus 2 divided by only 2 minus 2 cos 2x, right? So we see that these two terms are going to cancel out, and these two terms add up to be 1. So 1 over 6 into 1, and similarly we have a 2 here, so I'm going to write down 2 here, and we have cos 2x and minus 2 cos 2x, so we will be left with minus cos 2x, right? So now we can write down 1 over 6 into 3 minus cos 2x, which can be written as 3 over 6 minus cos 2x divided by 6, which is equal to 1 over 2 minus 1 over 6 cos 2x. Now we complete the solution, which was the general solution, and now we can write the general solution as y equal to c1 cos x plus c2 sin x plus 1 over 2 minus 1 over 6 cos 2x. And this will be our solution to the problem. This is the final solution, and I hope I explained it well. And if you don't understand anything, you can always ask in the comments. If you would like another video made for another problem, you can just write in the comments and I'll try to make that video. Thanks for watching.